Good morning, everybody. As mentioned, my name is Adam Sieben, and I am the tooling manager here at Trelleborg. Today, I'd like to share with you how having our tooling team's fingerprint on your manufacturing process will stage your project for the highest level of success. So with that, let's get started. As Chris mentioned earlier, being involved early and often on your project is crucial to a cost-effective product launch. We truly can partner with you from the ground up at Trelleborg. This allows us to understand and plan for the end vision of your project, whether that's high volume part production or prototyping. We'll take into consideration all aspects of the scaling process, whether that's automation, machine capacity, or sustaining capability. We understand that this may affect your part design, but our team of experts are available and ready to assist you and address any of those concerns with you as a partnership. We feel this is one of the most important tools that we can offer our customers, and we pride ourselves on making just simple part design changes for a better overall product. So in the coming slides, I'll walk you through how having access to our tooling and engineering team will contribute to your project success. So our engineering team plays a large role in establishing the communication bridge between the manufacturing process and our customer to ensure that it's a successful project for both Trelleborg and our customers. Our goal is to give you direct access to our in-house experts to give you the most accurate and up-to-date information to aid in your decision making. We utilize the latest mold flow and design software to assist with items such as cavity balance, maybe air trap or vent locations, even analyzing for material-based calculations such as waste material volume or press tonnage. Combining our highly experienced individuals with a superior software allows us to bypass many build and modification stages only to rinse and repeat. Having confidence in the process so that we can move forward into the prototype stage. To do this, when we move into the prototype stage, we take advantage of our internally designed and engineered tooling platforms, which gives us the ability to move quickly on your turnaround. We also document these lessons learned so that we can apply these to the next phases of your project, giving you the capability to work with one partner from concept to high volume production. During the development stages, we're able to utilize 3D printing to either create one-off components or a family of components. This is the quickest way to get parts in your hand. You can test form, fit, function, or maybe just generate further conversations on the project. A good example of this might be printing an entire shot volume of a mold to test the gauge structure. Now, 3D printing is trending now and has been for the last 15 years. The type of printing that is required for your application will depend on your product. The three factors that will feed into that are the speed of the printing, the layer accuracy, and the material type. Our SLA printer has the ability to print 25 micron layer accuracies and 20 different material types. Oftentimes we can print a series of products overnight and test the next day versus traditional methods of machining that may take days or weeks. And this can demonstrate some of the power of our capability to reduce our lead time. An additional form of 3D printing, the FDM type printing, while we can use this to print customer parts for just testing and visual aspects, a more typical application is to create complex machining fixtures or inspection fixtures. We also utilize this for end of arm part picking. It allows us to create organic shapes with ease. So to this point, most of our conversation has revolved around working with Trelleborg in the pre-chip stages of your project. There's an important connection that's often overlooked or seen as a one-size-fits-all, but that couldn't be further than the truth. The glue that bonds the engineering and the tool build together is your software. Anybody who's familiar with pulling in 3D CAD models has seen surface gaps or disorientated surfaces. If your software or personnel cannot manipulate these issues, those errors will be pushed directly into your part. We have at Trelleborg here access to multiple CAD systems to address these issues. One example I have on the screen here is our toolpaths may look smooth from afar, but if we look closely at that image, you can see a slight gap in that surface and what it does to that toolpath. So now the result of that will lead to broken tooling and an unpredictable process, which will increase your lead times. An additional important software that we have is machine simulation. This allows us to identify collisions or any corrections that are needed before we place our programs in the machine, to build our confidence to move swiftly from programming to setup to running. Trelleborg invests heavily in software to ensure that we have the highest level of manipulation, to avoid phrases from our teams like, I know what I want to do, I just can't figure out how to make the software to do it. But for the best results, 3D models are generated at the concept stage with manufacturing in mind, to reduce delays in development. So our commitment to providing high quality tooling fast continues into our tool room. We understand that to follow through on this commitment, we need to control that process. Sending just one process out may lose days on that project. So let me explain how we make this possible. What you see in the image on the left is this generation's version of a Bridgeport. It has user-friendly control, intuitive embedded cycles, and it's great for preheat treat items, fixtures, even mold bases. Well, this machine's not out of the ordinary for a tool room. We've added 1,000 PSI through spindle coolant to it, which allows us to create 6-inch deep holes and longer in a matter of seconds in one setup, which increases the accuracy and also decreases the opportunity for error with multiple setups. These small differences are what set us apart. Our tool room also houses 3, 4, and 5-axis high-speed milling machines. With the new technology, the expectations couldn't be higher for this type of machine. A high-quality, high-speed mill has the ability to process code before that movement takes place to ensure that the motion remains smooth and accurate throughout the cut, to produce ultimate surface finishes and accuracy. This will also negate the need for polishing. An additional characteristic that your high-speed machine will have is the capability for thermal compensation. This, again, allows you to maintain that accuracy for extended periods of time, allowing you to run unattended and automated with predictability. At Trelleborg Tooling, we're always looking to process in-house to dictate our quality. The conventional EDM or sinker EDM has been around since the 40s. Once it was seen as the most accurate way to create deep ribs, undercuts, hardened threads, and even sharp corners. It uses a highly controlled, electrically charged and shaped piece of graphite to erode the steel away as it nears contact. Our machines have adaptive controls to avoid pitting and consistent surface and maintain consistent surface finishes. We also utilize an application called high quality surface finishing. In this process, we add an additive to our dielectric fluid, which acts as a polishing compound, leveling out the peaks and valleys to replicate a polished surface finish and maximizing the application. The sinker EDM sibling, the wire EDM, is a very similar concept, but instead of the graphite material, we're using a hair-like piece of brass. This can be down to 0.004 of an inch in diameter, and typically was used for profiling parts, whether that's long, deep holes or through holes. But today's machines are capable of 3 and 4-axis processing, features such as sprues or cam locks. Doing what we do, though, we've added wire spitting to our wire EDM. This is similar to a lathe application, but with the reduced cutting pressures now, we're able to create delicate features with ease. We also have a rigid boxway lathe with sub-spindle handoff to create our hardened cavity cores from start to finish. This allows us to minimize handling of that part, as well as having the sub-spindle handoff. We've also added live tooling to our turret to create simple milling features to reduce secondary machine setups. This increases our capacity in other areas, as well as reduce costs in the manufacturing. So multitasking is a great human trait. Our Swiss type machine is the leader in multitasking. We can produce high volume, tight tolerance substrates for overmolding or for individual piece parts. We've added bar feeders to obtain lights out machining for days or even weeks off of one setup. Having this ability allows us to control and communicate part tolerances of our overmolded substrates in real time. This allows us to eliminate line down states due to quality or supply chain shortcomings, and gives us better quality in-house faster. While the need for historic manual machines has decreased with the technology increases in our other areas, to main focus on quality, tooling fast, we still need some of these items in our shop. So something like heat treatment of metal, if you send that out, may take a week or multiple days. We can do that in-house overnight, keeping that in-house and again, controlling that quality. So earlier on, we established that our CAD/CAM, or our software system, is the connection between engineering and tool build. Tooling is the connection between our tool build and our quality. You're only as good as your weakest link, right? So you wouldn't buy a high-end sports car and put inexpensive tires on it. That would drastically reduce the performance of that machine. Tooling is really no different. So here at Trelleborg, we've invested deeply into our tooling and purchased industry-leading, tight tolerance, repeatable tooling, and use the purest materials for mold component construction. This allows us to reduce our runout, increase our surface finish, maintain accuracy, while extending our tool life and reducing consumable costs. This standard is established across all of our sites at Trelleborg to ensure that we have these items in stock, on the shelf, and ready for your part detail. Our tool room is not immune to the battles that any other shop is incurring, and one of the biggest hurdles is obtaining and retaining employees. To combat these shortages, we take advantage of off-hour machine processing via robotics. Most of our machines are paired with robotic tending cells to increase capacity, to reduce cost and lead time. As we approach our final steps, quality verification is building confidence that we've achieved what we've set out to do. The earlier we can validate this process, the more efficient we'll be. We achieve this in a few different ways. So all of our machines are equipped with spindle probes to allow us for in-process component inspection. We also have automated tool setting and broken tool monitoring to aid in the peace of mind that when we're running lights out, that everything is going well, but also alerting our operators that corrections may be needed and reduces our downtime. We have dedicated toolroom CMM and vision inspection equipment, which eliminates the need for us to send our items to the quality lab to get into their inspection queue, only to find out that we need to place that item back into our machine to make some additional modifications. In the event that we do need to make modifications, we utilize precision zero-point fixturing. This assists us in multiple ways. It allows us to run automation while we're manufacturing, but also gives us the ability to machine an item, remove it from the machine, inspect it, and then place that back into the machine without an additional costly setup. Just place the item and go. Our quality does not stop in the physical form though either. We utilize file management software to control file configurations to release to build workflows. Every one of our components is laser marked or engraved with a unique ID on it that matches the CAD associated with it. This allows us the traceability to rebuild components to the exact version they were released. I think we can all agree that developing tooling fast is an advantage. Developing out-of-spec tooling fast is not an advantage. Trelleborg maintains a standard that quality and efficiency must be achieved together. The cost reduction will be a natural result. We place a high importance on training and developing our individuals to create predictable manufacturing processes under one umbrella to offer confident, premium tooling fast from the base up.